Warm greetings and very good morning, dear friends and students. Today we are going to see about the lecture video on the case of the solid shaft. What about the polar moment of inertia of the solid shaft and hollow shaft? And also we are going to give the equation of the section modulus and the polar modulus of the solid and hollow shaft section. You know that in the case of torsion of shafts, so we are in need of the polar moment of inertia and the polar modulus. So what is called as the polar moment of inertia? Polar moment of inertia of a solid circular shaft which is of diameter small d is given by the ratio of is the addition of the polar moment of inertia of the x axis and polar moment of inertia of the y axis. So we know that the polar moment of inertia is the summation of Ixx and Iyy. That is moment of inertia about the horizontal as well as the vertical neutral axis. You know that for a solid circular shaft, Ixx is equal to Iyy, that is equal to pi d per 4 by 64. So therefore Ip is equal to Ixx plus Iyy, that is equal to pi d per 4 by 64 plus pi d per 4 by 64. So you are getting 2 into pi d per 4 by 64. So if you are simplifying it, pi d per 4 by 32. So the polar moment of inertia of a solid circular shaft is pi d per 4 by 32. So what about the polar moment of inertia of a hollow circular shaft, which is of external diameter capital D and the internal diameter small d? So here Ip for the hollow circular shaft is equal to Ixx plus Iyy. So that is equal to pi by 64 into capital D per 4 minus small d per 4. So plus again pi by 64 into capital D per 4 minus small d per 4. So because the hollow circular shaft is symmetrical, so that's why Ixx is equal to Iyy. So that is equal to, right, pi capital D per 4 by small d per 4 divided by 64 into 2. What will happen? So if you are simplifying it, pi by 32 into capital D per 4 minus small d per 4. Now coming to the polar modulus of the solid and hollow circular shaft. So in the case of the polar modulus, it is the ratio of the polar moment of inertia of the shaft section divided by the maximum radius of the shaft. So in the case of solid circular shaft, the maximum radius is small d by 2 from the neutral axis. So at the top and bottom fiber, you will get the maximum radius. So if you are substituting the case of polar modulus, Zp is equal to Ip divided by R max. Ip is pi by 32 into capital D per 4 minus small d per 4 divided by R is equal to capital D by 2 in the case of hollow shaft section. So that is equal to pi by 16 capital D in the numerator capital D per 4 minus small d per 4. The unit is millimeter cube. So because Ip divided by maximum radius, so millimeter per 4 divided by mm. So that's why you're getting millimeter cube. In the case of solid circular shaft section, which is of diameter small d, again the polar modulus Zp is equal to Ip divided by R max. Ip is pi into capital D per 4 divided by 32 divided by the maximum radius is small d by 2. So if you are simplifying it, you will get pi d cube divided by 16 in terms of millimeter cube. So this is about the polar modulus of the hollow shaft and the solid circular shaft. So it is denoted by capital Z suffix P, where P stands for polar modulus. So what we have seen in the case of beam, we have seen the section modulus of the beam. So what is section modulus? Section modulus of the beam is nothing but the ratio of the moment of inertia about the common axis, that is neutral axis, divided by the maximum distance from the neutral axis, that is the top and bottom fiber distance. So it is calculated in terms of the moment of inertia, the summation of moment of inertia about the x-axis plus y-axis divided by the maximum fiber distance. So already we have done about the section modulus of the beam for the rectangular, hollow rectangular, circular and hollow circular shaft section. And also we have seen the problem in the case of the section modulus. So in the next video lecture I can cover about the problem in the case of the polar moment of inertia and the polar modulus of the circular as well as the hollow circular shaft. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.